manufacture of something now more precious than gold, America's motor cars. We must keep these cars rolling. We must make every motor run better, longer. These are the cars of today, the cars that must carry on for America. The automobile, like the locomotive, has changed tremendously. A decade ago, this lightweight high-speed train would have been a complete stranger. 10 years ago, the giant clippers were only a dream. Today, a powerful, comfortable means of taking people through space over vast distances. But look at the modern automobile. It's easy to forget the engineering improvements, the mechanical changes under the hood. But the changes exist, and they mean something to all of us who are trying to keep them rolling. Let's look under the hoods of this new car and the car of a few years ago and see what's been going on. Here is the compact power plant of today, a sensitive and precise mechanism. Here is the bulky motor of 10 years ago. Yes, changes are apparent to the eye, all right, but it's inside the motor where the real changes have been made. In older cars, clearances between pistons and cylinder walls were not close enough to permit development of full power. It's a different story in today's car. Clearances between pistons and cylinder walls have been reduced by approximately 50%. And look at a bearing in an old car. Clearances were comparatively wide, affecting the smoothness and the efficiency of engine operation. But not today. In the modern car, the clearance between bearing and shaft is about 83% less than it was just a decade ago. That may sound like a small matter to you, but it's a big factor in engine performance. Another important change which makes the modern car faster and more powerful. The pistons compress the air and gasoline mixture tighter. In other words, the compression ratio is higher. Here is where compression ratio is determined, in the combustion chamber. In the old car, we had a compression ratio of 4 6/10 to 1, meaning a fairly large combustion chamber. In the new car, the compression ratio is 6 6/10 to 1, meaning that the combustion chamber is smaller. The gas and air are squeezed 44% tighter. The whole story of compression can be illustrated by this steel spring. The tighter you press the spring, the more force is exerted when the spring is released. The tighter you compress a gas mixture, the more oomph, the more power you have when the mixture burns. All these improvements, smaller clearances between moving parts, higher compression ratios, mean a lot more power. The modern car is more than a third faster than its 1925 brother. And that means every part moves faster. At 50 miles an hour, the crankshaft on an average motor rotates 42 times per second. Is that fast? Try winking your eye just 5 times in 1 second. In 1 second, there are 504 piston strokes. 504 strokes per second. Faster moving parts mean just one thing: more friction. More friction means more heat. Higher compression means more heat. And more heat requires better lubrication. Think of it this way. Rubbing your hands together makes them warm and rough. A few drops of water will lubricate and cool the hands as long as the water lasts. But if the water is supplied in constant volume, it carries off the heat. Your hands are well lubricated, and they stay cool. The same thing goes inside an engine. The 400 to 500 moving parts in the average engine must all be lubricated and cooled to keep out wear. No matter how remote, no matter how small, each part must get its share of friction-fighting lubrication. The oil must flow over and through and around each moving part constantly to cheat friction and keep the engine cool. And the greater the flow to all these parts, the better the job is done. Out of the Sun Oil Company's years of research has come the answer to this lubrication need. Today's reinforced Sunoco motor oil. Why is it so superior? Why does it make motors run better, longer? The answer starts in the vacuum fractionating towers of Sun Oil's mercury plant, the only one in the world. What's the purpose of the mercury? The heating of oil may be done in various ways, usually by furnace fire. But the most precise and perfect is by heated mercury vapor, which can be controlled to a minute degree. Let's take a look into the mercury plant. The first thing to observe is a sample of the crude oil from which the lighter parts have been removed. The charging stock, black and raw. It contains many fine oils, all mixed together. They must be separated. And that giant manifold carries the heat for the job. Through it passes hot mercury vapor, controlled heat. The mercury vapor does not touch the oil, but heats it much as a double boiler cooks oatmeal. There's a precision of temperature control never before approached in refining oil. Into those towers, different oil vapors have risen, which now, cooled and liquefied, pass through those pipes. A different grade of oil in each pipe, some light, some medium, some heavy. The peep box, where we see one of a number of finished oils. From the black charging stock we saw before, we have now taken out clear and pure Sunoco motor oil made by the mercury process. This all sounds rather complicated. Let's see if we can simplify it with this drawing. We start with the black charging stock we saw in the beaker a moment ago. The charging stock flows over a vaporizing plate. Hot mercury vapor in a separate section below heats the vaporizing plate. This works like a double boiler. The mercury never touches the oil or the oil vapor. It cannot pass the vaporizer plate. Some of the flowing oil changes to vapor. It rises into the fractionating tower above. Up to the top of the tower go the undesirable and impure parts. These are the portions we don't want in the oil. So, out they go. Lower down, the golden lubricating oil condenses, flows out to be cooled, then goes into the receiving tank. Heat, too much or too long, is the enemy of good motor oil. It cracks or decomposes it. But in the mercury process, the highest temperature that the oil can touch is only about 750 degrees, compared with 1400 degrees in the ordinary refining furnace. This lower heat is possible only because a vacuum is created over the oil as it flows down the vaporizer plate. The vacuum virtually sucks out the oil vapors. That's how each of these towers works. A different grade of oil comes from each tower. SAE 10, 20, 30, 40, 50, 60. A complete range of modern motor oils. How do these oils test? How do they compare with the well-known premium-priced motor oils? Does Sunoco lubricate better, reduce wear, make engines run better, longer? Let's see with our own eyes. Here is a complete array of modern devices designed to measure the performance of motor oils under conditions duplicating those inside an automobile engine. This is an apparatus for measuring the comparative flow of oils under conditions duplicating those in a running motor. There are two oil systems operating under the same conditions. Same temperature, same type of oil pump, same size oil passages, same pressures. Both are driven by the same motor. Equal quantities of Sunoco oil and the competitive premium-priced oil of the same SAE number are measured for the test. Sunoco oil is poured into one crankcase, the competitive oil into the other. The heat switch is turned on, and the oils are brought to motor operating temperature. Now, with the machine in operation, notice that both pressure gauges are the same. Also notice that the competitive oil on the left is only about halfway up the tube, while Sunoco on the right is at the top. This thermometer registers 210, normal crankcase operating temperature, and the other thermometer registers the same, proving that in your automobile, Sunoco flows to the moving parts in greater volume. Here is a device which shows the value of more oil flowing to the moving parts. A reservoir of oil and two metal pellets have each been heated to engine operating temperature. About a third more oil is pouring over this pellet. Now let's look at the thermometers. The thermometer on the right drops more quickly, and that's the pellet that is receiving the greater flow of oil. We have seen that greater volume means greater cooling. Greater cooling means less wear, proving that Sunoco oil gives greater protection to all moving parts of your engine. This strange-looking device tests another highly important quality of motor oils, their comparative film friction. In plain English, their slipperiness. That inclined surface is built of glass, heated by steam to engine operating temperature. Two test oils, Sunoco and a competitive premium-priced oil, both of the same SAE grade, and both heated to engine temperature, are poured over the sloping glass plate, divided into two parts to make two steam-heated runways. The competitive oil has already been poured. Now we pour on the Sunoco. Two highly polished metal discs of the same size, same weight, and made of the same metal, heated to engine temperature, are going to be released at the top of the runways. They're off. Let's stop the camera when the Sunoco disc reaches the bottom. The competitive disc still has 1/3 of the way to go, proof that Sunoco motor oil makes surfaces more slippery. But besides keeping surfaces slippery and preventing wear, motor oil has other important jobs to do. It must keep hard carbon out of combustion chambers, must keep pistons clean, rings free, and valves free from harmful deposits. Clean combustion chambers quickly let the excess heat get through cylinder walls and into the cooling system. As a result, the gasoline mixture, when ignited, burns smoothly, evenly, powerfully. When a cast iron bar and a carbon bar are held in a flame, it is only a few moments before the rapid flow of heat forces the holder to drop the iron bar. But the piece of carbon can be held in the same flame almost indefinitely because it does not readily transmit heat to the hand. In the same way, combustion chambers lined with hard carbon prevent the free passage of heat into the cooling system. Instead of burning smoothly and powerfully, the fuel mixture pings, knocks. It explodes like dynamite. Thus, to make motors run better, longer, oil must protect this vital section of the motor. Let's see how well Sunoco does this job. This demonstrator consists of a cylinder, a split piston and ring assembly, which has been preheated to engine operating temperatures. The operator turns on the drip cups, one of which contains Sunoco motor oil, the other the same quantity and grade of competitive premium-priced oil. Now, a gasoline flame is directed over the piston head. That's real heat, terrific heat, much like the gasoline explosions constantly occurring in your motor. Both of the oils under test are subjected to the flame. What effect has the heat had on the two oils? Let's take the piston out, cool it, and see. There's a tremendous difference in the type of the deposits on the two sides of the piston. Look, the Sunoco side can be wiped clean. This deposit is soft, and in motors is carried away with the exhaust. The combustion chambers stay clean. But look at the other side, a hard, varnish-like deposit. And now let's look at the rings. The Sunoco lubricated rings are free-acting, free to seal in power. But stuck rings like these can't seal in anything except themselves. These rings are power pilots. A tough test, but Sunoco can take it. Surely this demonstration has proved that Sunoco motor oil, due to its extreme purity and inherent qualities, keeps rings free and combustion chambers free of hard carbon. In this unique demonstration, the operator puts two identical valves into the machine. Notice that the valves slide easily in the guides. We're going to make a comparative test of the effects of oils on valves in action under motor operating heat. On one valve, we use Sunoco, and on the other, a competitive premium-priced oil of the same SAE grade. Equal quantities of oil drip over the hot-moving valves and valve guides. The valves are cooled. Now let's see. How freely do the two valves move in their guides? The valve and guide lubricated by the competitive oil, as you see, are sluggish, slightly stuck. Wouldn't work very efficiently in the modern high-speed engine. The Sunoco lubricated valve moves freely. Sunoco oil keeps valves free-acting, keeps motors more powerful, keeps motors running better, longer. Here's a startling fact for you. The engine of your car breathes in vast quantities of air. 6,000 cubic feet of air for every hour you drive. And practically all of this air that goes into the engine comes in contact with the lubricating oil. Let's try to duplicate this condition. We take Sunoco and an ordinary oil, same quantity, same SAE rating. The beakers into which we pour the oil are on an electric stove, which will bring the oil to average engine operating temperature and keep that temperature for the duration of the test. The operator turns on the heat, then places the tubes, which are connected with the compressed air tank, into the beakers. Now, as a final step, we turn on the compressed air, an equal quantity of which is fed to each of the two beakers. Thus, throughout the test, we will have air bubbling through the heated oil. The test is completed. Let's see what the air has done to Sunoco and the ordinary oil, which have been subjected to the same heat, have been fed the same amount of air for the same time. The oxygen of the air has combined with certain portions of the ordinary oil, causing it to thicken. Its lubricating quality is impaired. But reinforced Sunoco oil is still fluid and live-bodied. It resists the harmful effects of air. It stands up. Through all of the tests we have seen, clear, pure Sunoco motor oil stands up, just as it stands up in motors. Here is an oil, mercury made by science, product of the only plant of its kind in the world. Here is an oil proved by these tests to be more slippery, an oil that flows through close-fitting bearings in greater volume, providing greater cooling, ensuring less wear. Here is an oil that keeps valves free-acting, keeps combustion chambers clean, free of not producing power-killing hard carbon. Here is a tough, live-bodied oil, proved by test to give positive protection to all your motor's vital moving parts. Today's reinforced Sunoco motor oil works hand in hand with modern motors, keeps that complicated, valuable piece of machinery, today's motor car, running better, longer.